Okay, here's a tutorial on solving rational equations and the rational function. This is 2.3.2 in our Math 2 curriculum. Alright, so what I want you to do real quick is to pause your screen and get down some of these notes that I have already written out for you for rational equations, excluded values, and steps for solving. You'll just go ahead and get those copied down. Alright, so what I want to do is just real quickly go through these with you. A rational equation is an equation with fractions in it, so we have to be aware of denominators, and there are techniques to deal with that, as well as excluded values that we have to be aware of. In this function, there are places where values are not defined on the function, so we have to be aware of those. Those values typically are values that would make the denominator of our fraction a 0. And we know that dividing by 0 is undefined in the real number system. I do have some steps for you to solve a rational equation. Notice that I talked about setting up a proportion. That's where a fraction is equal to a fraction. So each of these scenarios that I go through will include a proportion. Alright, so I'm just going to work this first example, example 1, with you right here. Again, when we're talking about a fraction equals a fraction, that allows us to use the cross-multiplying technique. So when I say cross-multiply, that means diagonally across the equation, because what we're doing is just trying to get rid of the fractions. As there are fractions, it makes our life a little bit more difficult when we're solving. So this cross-multiplication technique allows us to get rid of those fractions. So bottom of the left times the top of the right, top of the left times the bottom of the right. 3 times x is 3x. 6 times 7 is 42. Again, that was 3 times x equals 6 times 7. Just to make it real clear, now I'm just going to solve my equation, divide both sides by 3. X is equal to 6. Alright, a little bit more challenging is when the denominator has a binomial in it. So again, we're going to cross multiply. So 6 times x minus 7 and 4 times x. Well, now I need to make sure I distribute on the left side. 6x minus 42 equals 4x. And now I need to isolate the variable. So I'm going to subtract 6x from both sides. And that's going to give me negative 42 is equal to negative 2x. Divide both sides by that negative 2 to isolate the variable. And 21 is equal to x. Alright, again, furthermore challenging is when I have binomials on both sides, but again, I'm still cross multiplying. So x plus 4 times 1 and negative 5 times x plus 4, but this should kind of give me a little bit of pause, as I'm telling you that negative 5 divided by x plus 4 is equal to 1 over x plus 4. So I'm already a little bit curious about how this is possible. So let's see what happens, because something tells me here that we're going to end up with some excluded values as well as some solutions that don't really work for us. So here we go. 1 times x plus 4 equals negative 5 times x plus 4. Okay, so I'll go ahead and distribute 1 times x and 1 times 4 is x plus 4. Negative 5 times x and negative 5 times 4 is negative 5x times negative 20. Now I want to try to get the x's with the x's and the numbers with the numbers, so I'm going to go ahead and add 5x to both sides. And I get 6x plus 4 is equal to negative 20. Now I'm going to subtract 4 from both sides, and I get 6x is equal to negative 24. Divide both sides by 6, and x is equal to negative 4. And then I should take a look at the fact that under here are our previews of what is the excluded values. For instance, I'm looking for anything that makes the denominator 0. Well, so x plus 4 equals 0. That would mean in order for that to happen, x would have to be equal to negative 4. Well, look at what the answer is that we just solved for. And that's why our equation looked like it did from the beginning, where it seemed like it couldn't happen. Well, it can't happen because the only answer that we got was one of the excluded values. Therefore, there is no solution. In example number 4, what would our excluded value be? Well, that would be x can't be equal to -5, because if I plugged in a -5 in for x, I would get a 0, and we can't divide by 0 and still have a defined value in the real number system. So keep it in mind that if my answer is -5, I'm going to have no answer. Cross multiply 6 times 6 and x times x plus 5. Now right away, I'm starting to recognize that this is going to be a quadratic, which means I'm going to have to use one of my quadratic solving techniques. 36, okay, 6 times 6 is 36, and x times x is x squared, x times 5 is 5x. Had to make sure I distributed there. Now it's a quadratic, which means I need to set equal to 0. Subtract 36, subtract 36. And I've got 0 is equal to x squared plus 5x minus 36. And now I need to solve this quadratic equation. I'm expecting 2 answers, and I'm trying to make sure that neither one of them is -5. Now the technique that I would do here is I would use the quadratic formula, but some folks would prefer to use factoring. Some folks might even like to complete the square. We'll go ahead and do the quadratic formula just to brush up on that. So this is my A value, my B value, and my C value. So when I go to do the quadratic formula, the opposite of B is -5 plus or minus square root B squared, so that's 5 squared minus 4, the A value 1, the C value -36. All of that's over 2 times the A value of 1. All right, now I'm going to work my way from the inside out. So I'm going to simplify the, underneath the radical, the radicand, I'm going to simplify that first. So I've got -5 plus or minus the square root of, now 5 squared is 25 plus 4 times 36. Well, 4 times 36 is going to be 144. So I've got 25 plus 144 all over 2. Continuing to simplify, -5 plus or minus the square root of 169 over 2, which -5 plus or minus the square root of 169 is 13 over 2. And now I can split into my two scenarios, -5 plus 13 over 2 and -5 minus 13 over 2. And this will give me my two answers. -5 plus 13 is 8. 8 divided by 2 is 4. -5 minus 13 is -18. -18 divided by 2 is -9. So my two answers are 4 and -9. Neither of those are -5, so these are my answers for that quadratic equation. Next, I want to skip down to an example with you where I don't have a proportion from the beginning and I need to turn it into a proportion. So before we were lucky because it was a proportion from the beginning, 2 fractions, fraction equals a fraction. Now I have this constant term that I have to somehow turn this into a fraction so that I can have a proportion and I can cross multiply. All right, so in order to do that, what I need to do is get a common denominator, which means that I need 4 to then be divided by x minus 3. All right, well, in order to do that, I'm going to have to multiply by some number that's not going to change the value of 4, but still can make it a fraction. Well, that means I'm going to multiply by whatever the common denominator is on the top and the bottom of my fraction. So if you don't know what I'm talking about, let me just write out where I'm headed here. So at the moment, I've got 4 over 1 as my second term in my binomial to the left side of this equation. So I need to make this denominator an x minus 3 so I can multiply that by x minus 3. But if I multiply this by x minus 3, I've got to do the same thing to the top because x minus 3 divided by x minus 3 is equal to 1. And multiplying by 1 keeps everything the same as what we started with. So here we go. Let me show you what we're going to do. So 7x. So here we go. 7x divided by x minus 3 plus, and now I'm going to multiply by x minus 3 over x minus 3. And that's going to be equal to what's happening over here on my right side. So then that means 7x over x minus 3 plus distribute 4x minus 12 over x minus 3 equals x plus 1 over x minus 3. Now, I can combine these top terms because of the common denominator. So x minus 3 on the bottom, 7x and 4x is 11x, minus 12 equals x plus 1 over x minus 3. And now, with the denominators like they are, I could cross multiply, or I can even recognize the fact that because they have the same denominator, the numerators must be equal. So instead of cross multiplying, I can actually skip that step and say 11x minus 12 is equal to x plus 1. And again, I was able to do that because these two denominators are the exact same. If they weren't, I would have to cross multiply. Got lucky on that one, so now I'm solving. Subtract x from both sides. 10x minus 12 is equal to 1. Add 12 to both sides. 10x is equal to 13. Divide both sides by 10. X is equal to 1.3. I want to finish up with one of these where I end up having to cross multiply multiple binomials. And I also want to point out, because I'm starting to get out of the habit of identifying the excluded values. So here, the value that would make my bottom of my left side of the equation 0 would be negative 8. So my excluded values would be negative 8 on the left side and negative 2 on the right side, because if I plug in a negative 2 right there, I would get a 0. So those are my excluded values. My answers cannot be either one of those two things. Now I want to cross multiply here. So 8 times x plus 2 and x times x plus 8. Again, I'm going to end up with a quadratic here, so I'm going to have to do some quadratic solving. 8x plus 16 is equal to x squared plus 8x. That happened because of distribution. Now I want to set this thing equal to 0. Subtract 8x from both sides. And I get 16 is equal to x squared. And then these cancel. Amazing. So 16 is equal to x squared. Now at this point, I could take the square root of both sides in order to get x squared by it, or the x by itself. But keep in mind, when you take the square root of x squared, you need two answers. So you've got to have plus or minus the square root of 16. Well, the square root of 16 is 4. So x is plus or minus 4. Well, if I write them as two separate answers, that's what they look like. And I just double check that they're not an excluded value. They're not, so I am good to go.